In this video, we will be looking at building a Blinky project from scratch on a RA6 microcontroller. We begin by opening our workspace in A Square Studio. In this workspace, we create a new C file. We click on Next. Let's name the project My Blinky. We click Next. This will open the Device and Tools selection menu. We select the EK-RA6M4 as the board, and that will pre-select the device name, and we select it as a flat project executable with no RTOS, and we select bare metal. Once we click Finish, the project will be initialized, and we can see that the chip is initialized with very few ports configured. In order to make a Blinky project, we shall make use of the user LEDs present on the evaluation board. From the user manual, we can see that there are 3 LEDs connected to the pin 404, 415 and 400. From the datasheet of the RA6M4 microcontroller, we can see that there is an on-chip high-speed oscillator. We shall make use of these on-chip oscillators for our timing operations, such as the delay. From the FSP configuration perspective, we can see that the on-chip high-speed oscillator is already selected. Next, we configure the pin that is connected to the LED. We choose pin 400, which is connected to the LED 3 on the board. We name it My LED 3. We initialize the mode of the pin as an output pin with an initial low value. This also changes the pin into a GPIO pin. As the pin is configured, we can now generate the project contents for further programming. We then change into the C perspective. We then look for the hull entry.c file under the source folder. This is where we will be putting our code. There are some initializations in the file. What we are interested in is the hull entry function. We start by writing a while loop. We can find the required code under the Developer Assistance tab. For this case, we need to write in the pin. So we will look for pin write. We can drag this to the code window and modify it as required. Next, we fill up the arguments in the code. In order to find the level definitions for the pin, we can take help from the FSP manual. From the manual, we look for information on the I/O axis. From here, we can find how the levels are defined in the FSP, and we can copy it and put it back into our code. Next, we find how to define the delay or timing on this board. This can also be found in the FSP user documentation. We copy the relevant line and put it back into our code, and we add in the arguments. On the first step, we want the LED to be on for 250 milliseconds. We can now simply copy these lines and change as we need. We would like our LED to blink for 2 different durations. So we make the necessary changes in the timing function arguments. Once the coding is done, we have to build our project by clicking the build icon. Once the project has built without any errors, we can plug in the supplied micro USB to the debug 1 port of the evaluation board. Once the program has been debugged and uploaded to the board, we can run the code line by line by using the resume button. Once we arrive at hull entry function, the LED will start blinking as per the timing we set. And that completes our simple Blinky project.